Hello, everyone. Welcome to my DataCamp tutorial series. I'm Professor Adam Kroom, and today we will focus on Introduction to the Tidyverse, Chapter 2. And Chapter 2 focuses on data visualization. Variable assignment. Throughout the exercises in this chapter, you'll be visualizing a subset of the Gapminder data from the year 1952. First, you'll have to load the ggplot2 package and create a Gapminder underscore 1952 dataset to visualize. Instructions. Load the ggplot2 package after the Gapminder and dplyr packages. Next, filter Gapminder for observations from the year 1952 and assign it to a new dataset, Gapminder underscore 1952, using the assignment operator. All right, so we'll go over to the right-hand side. And we've already have Gapminder and dplyr loaded. So what we have to do now is load the ggplot2 package as well. So we'll use the library function to load ggplot2, to load that package. Next, we have to create a Gapminder underscore 1952 variable. So let's do that. Gapminder underscore 1952. So we are creating a new variable and we want to assign something to that. So we use the assignment operator. And what do we want to assign to that? Well, Gapminder, we want from that data set, we want to filter observations from the year 1952. So we're going to use the pipe filter year. What year do we want? 1952. And let's submit the answer. Great. If you typed Gapminder underscore 1952 now, you'd see the filtered data set. Press enter to continue. So let's continue to the next exercise. This exercise is called Comparing Population and GDP Per Capita. In the video, you learn to create a scatter plot with GDP per capita on the x-axis and life expectancy on the y-axis. When you're exploring data visually, you'll often need to try different combinations of variables and aesthetics. Instructions. Change the scatter plot of Gapminder underscore 1952 so that POP is on the x-axis and GDP per capita is on the y-axis. All right, so let's look on the right and see what we have to do. It says change to put POP on the x and GDP per cap on the y. So if we look at this, we can see that currently GDP per capita is on the X, but we don't want that on the X. We want POP on the X. So we just do that. Over here, we also see that life EXP is on the Y, but we don't want that on the Y. We want GDP per cap on the Y. So we'll type that in, GDP per cap. And now we've made the appropriate changes. Let's go ahead and submit our answer. Great work on your first graph. Each point represents a country. Can you guess which country any of the points are? And we'll go ahead and continue to our next exercise. So the next exercise is called Comparing Population and Life Expectancy. In this exercise, you'll use ggplot2 to create a scatter plot from scratch to compare each country's population with its life expectancy in the year 1952. Instructions. Create a scatter plot of Gapminder underscore 1952 with population on the X and life expectancy on the Y axis. Okay, so let's go ahead and look on the right side. And it's asking us to create a scatter plot with population on the x-axis and life expectancy on the y-axis. So we need to create a scatter plot. So we're going to use ggplot2. Or we'll use ggplot. So let's go ggplot Gapminder 1952. And for our AES aesthetics, X equals pop, Y equals live EXP plus geom point. All right, this should create a scatter plot with pop on the x-axis and life expectancy on the y-axis. Great. You might notice the points are crowded towards the left side of the plot, making them hard to distinguish. This next video will help solve that problem. So we'll go ahead and advance through the video, but I encourage you to pause the tutorial and make sure that you watch the video before we continue. And after you've watched the video, you can come back and pick up with this tutorial. The tutorial will focus only on the exercises. All right, so the next exercise is called putting the x-axis on a log scale. You previously created a scatter plot with population on the x-axis and life expectancy on the y-axis. Since population is spread over several orders of magnitude, with some countries having a much higher population than others, it's a good idea to put the x-axis on a log scale. Instructions: change the existing scatter plot to put the x-axis on a log scale. Okay, so let's see what we have going on the right. It says change this plot to put the x-axis on a log scale. So ggplot, Gapminder 1952, aesthetics, x population, y is life expectancy, plus geom point. So what we have to do here is just scale x log 10. And that should put this on a log scale. Great. Notice the points are more spread out on the x-axis. This makes it easy to see that there isn't a correlation between population and life expectancy. Cool, so let's continue to the next exercise. The next exercise is called putting the x and y axes on a log scale. Suppose you want to create a scatter plot with population on the x-axis and GDP per capita on the y-axis. Both population and GDP per capita are better represented with log scales since they vary over many orders of magnitude. Instructions: create a scatter plot with population on the x-axis and GDP per capita on the y-axis. Put both the x and y axes on a log scale. Okay, cool. So this is somewhat similar to what we did last time. Over here, we see on the right side, it's asking us to scatter plot comparing population and GDP per cap with both axes on a log scale. So ggplot Gapminder underscore 1952 AES for aesthetics, X is going to be population, Y is going to be GDP per cap. And then geom underscore point. Okay, and now we've got to put both on a log scale. So that's going to be what it's asking us is put both the x and y axes on log scale. So you can think of it, we got to do two things here. Scale underscore x underscore log 10. All right, that's one part. The next is similarly scale underscore y underscore log 10. And that's going to make sure that we got both the x-axis and the y-axis on a log scale. Let's submit the answer. Cool. Great. Notice that the y-axis goes from 1E3, right, 1,000 to 1E4, 10,000 to 1E5, 100,000 in equal increments. Yeah. So exponents. Press enter to continue. We'll move on to the next exercise. So again, we'll continue through the video and focus on this next exercise, which is called adding color to a scatter plot. In this lesson, you learned how to use the color aesthetic, which can be used to show which continent each point in a scatter plot represents. And in order to know how to do this, you have to watch the video. So just make sure that you're watching all the videos, okay? I'm gonna just simply presuppose that you've watched those as I help you answer these questions. So what's it asking us to do here? Well, the instructions say create a scatter plot with population on the x-axis, life expectancy on the y-axis, and with continent represented by the color of the points. Put the x-axis on a log scale. Okay, so if you look on the right, what we have to do is scatter plot comparing pop and life expectancy with color representing continent. So ggplot, right? We've already been doing this in the last few exercises. ggplot, Gapminder 1952, and then AES for aesthetics. X equals to what? Population. And Y equals to life EXP. And now color equals to what? Color represents the continent, right? It's saying right there, color representing continent. So set the color to continent. And now geom point plus, we want to put the, it says here, put the x-axis on a log scale. So to do that, we're going to go scale underscore x underscore log 10. And let's submit our answer. Good work. What differences can you see between continents in terms of their population and life expectancy? Cool, let's continue now to the next exercise. Next exercise is called adding size and color to a plot. In the last exercise, you created a scatter plot communicating information about each country's population, life expectancy, and continent. Now you use the size of the points to communicate even more. Instructions. Modify the scatter plot so that the size of the points represents each country's GDP per capita. All right, so what we're gonna do is look on the right. It says add the size aesthetic to represent a country's GDP per capita. Okay, so let's take a look at this and see where we can add the size aesthetic. So this looks good. X equals population, Y equals life expectancy, color equals continent. Well, we're gonna add, what are we adding here? Size, right? So just like we added color here, we'll add size after that. Size is equal to, and what is the size equal to? It says it wants the size of the points to represent the country's GDP per capita. So size is equal to GDP per cap. And then, let's see. So that's all it wanted us to do, was just add the size aesthetic. So that should be good. Let's submit the answer. Good work. Are you able to guess which point represents your own country? Cool, so let's continue. And we will continue past this video, but make sure you watch it. And we will continue with this exercise. This exercise is called creating a subgraph for each continent. You've learned to use faceting to divide a graph into subplots based on one of its variables, such as the continent. Instructions. Create a scatter plot of Gapminder underscore 1952 with the x-axis representing population, the y-axis representing life expectancy, and faceted to have one subplot per continent. Put the x-axis on a log scale. So if we look on the right-hand side, we see that we have to do this. Scatter plot comparing pop and life expect, faceted by continent. Okay, no problem. So we've already been doing this. So we're going to go ggplot and Gapminder underscore 1952, comma AES. X is equal to population. Y is equal to life expectancy. And then what do we have to do now is faceted by continent. Okay, no problem. So this is what we'll do. Plus, can't forget to do this, geom underscore point. And then it says put the x-axis on the log scale. So we'll go plus scale underscore x underscore log 10. And it wants us this faceted one subplot per continent. Right, so what we'll do is we'll go facet underscore wrap. And then this is one subplot per continent. So we'll go continent. And let's see if this works. Submit answer. Great work. Faceting is a powerful way to understand subsets of your data separately. So awesome. Let's move on to the next exercise. The next exercise is called faceting by year. All of the graphs in this chapter have been visualizing statistics with 1 year. Now that you're able to use faceting, however, you can create a graph showing all the country level data from 1952 to 2007 to understand how global statistics have changed over time. Instructions. Create a scatter plot of the Gapminder data. Put GDP per capita on the x-axis and life expectancy on the y-axis, with continent represented by color and population represented by size. Put the x-axis on a log scale and facet by the year variable. Okay, so let's go ahead and look on the right and see what we have to do. Scatter plot comparing GDP per cap and life expectancy with color representing continent, add size representing population faceted by year. Okay, so ggplot, gapminder, AES, x equals, what does x equal in this case? GDP per cap, right? Because it says over here, put GDP per cap on the x. So x equals GDP per cap, right? Cool. And then what's on the y? Y equals, and life expectancy on the y. So y equals life exp, and then with continent represented by color. So it says continent represented by color. So we'll put color equals continent. What else? And it says population represented by size. So we'll go size is equal to pop. Okay. What's next? Plus geom underscore point plus, we want to put the x-axis on a log scale, right? It says put the x on a log scale, so scale underscore x underscore log 10. And are we missing anything? Oh, faceted by year, right? The last thing it says faceted by the year variable. So we'll go make sure we use the facet wrap. And we're going by year this time, by the year variable. It looks like we've hit all of the instructions, so let's submit the answer. Awesome. That's a lot of information you're now able to share in one graph. So check that out. Nice looking graphs in R. So we'll go ahead and press enter to continue.